5.5, the substitution rule. Because of the fundamental theorem, it's important to be able to find antiderivatives, but our anti-differentiation formulas don't tell us how to evaluate integrals, such as equation 1, the integral of 2x times the square root of 1 plus x squared dx. Sidebar, differentials were defined in section 3.10. If u equals f of x, then du equals f prime of x dx. Back to the text. To find this integral, we use the problem-solving strategy of introducing something extra. Here, the something extra is a new variable. We change from the variable x to a new variable u. Suppose that we let u be the quantity under the root sign in equation 1, u equals 1 plus x squared. Then the differential of u is du equals 2x dx. Notice that if the dx in the notation for an integral were to be interpreted as a differential, then the differential 2x dx would occur in equation 1, and so formally, without justifying our calculation, we could write equation 2, the integral of 2x times the square root of 1 plus x squared dx equals the integral of the square root of 1 plus x squared 2x dx equals the integral of the square root of u times du equals 2/3 u to the power 3 over 2 plus big C equals 2 over 3 open 1 plus x squared close 3 to the power 3 over 2 plus big C. But now we can check that we have the correct answer by using the chain rule to differentiate the final function of equation 2. The derivative with respect to x of open bracket 2 over 3 times open 1 plus x squared close to the power 3 over 2 plus big C close bracket equals 2 over 3 times 3 over 2 times open 1 plus x squared close to the power 1 over 2 times 2x equals 2x times the square root of 1 plus x squared. In general, this method works whenever we have an integral that we can write in the form the integral of f of g of x times g prime of x dx. Observe that if capital F prime equals f, then equation 3, the integral of capital F prime of g of x times g prime of x dx equals big F of g of x plus big C, because by the chain rule, d over dx, the derivative with respect to x of open bracket big F of open, restarting this line, the derivative with respect to x of big F of g of x equals big F prime of g of x times g prime of x. If we make the change of variable or substitution u equals g of x, then from equation 3 we have the integral of big F prime of g of x times g prime of x dx equals big F of g of x plus big C equals big F of u plus big C equals the integral of big F prime of u du. Or writing big F prime equals f, we get the integral of f of g of x times g prime of x dx equals the integral of f of u du. Thus we have proved the following rule.